So in this video we want to look at what we call classification. Let me write this a little bit better, even though I can't write good. Classification of numbers. Now, classification of numbers are really just an idea that is used in mathematics as relates to the real number system. There are different types of numbers that we use when we add, subtract, when we find the square root of a number, when we actually find the square of a number, when we try to use different numbers in formulae and so on. And so we actually have specifically unique types of numbers in our real number system. And so we want to spend just a few minutes to look at them and to understand what are these kind of numbers. So the first thing that we want to look at is a set of number that actually we use basically every day. Well, it's from really at the basic school level, you have persons counting, you have students counting, and the teachers actually teach these students how to count. And so also we could actually look at it in a different way that we call them natural numbers. So natural numbers are counting numbers, are just numbers that we actually, when we actually refer to starting at 1 and it goes up to infinity and it continues. So counting numbers are numbers that start at 1 and it goes up. And so when you look at it, we call it a natural. It could also be called natural numbers because it's just a natural way of counting. Whenever we're counting, we normally start at 1. And so counting numbers are natural numbers. Are somewhat they are the same, but like you can call, it's like you're calling a person by his last name or his first name. If you say John and his first name is John, his second name is Smith. You're actually calling to the same person. So it's like if you say natural numbers, the same thing as counting numbers. And so we want to draw a number line and to just to actually have a little idea of something right here. Draw that line there, -1, -2, -3, and it goes on. Now, if I should actually look at these kind of numbers, these are called the counting numbers, and they continue up to positive infinity. And let's say that all of these numbers are having a party, and one actually gets drunk and he steps over the boundary, and he actually is not in his natural number zone, but he's actually in a zone that he's seeing an unfamiliar number, which is 0. And so he says to 0, hey, what are you doing here? And 0 says, I'm just here trying to find some other numbers to play with. And 1 says, hey, you can play with us. I have a large family up to positive infinity. And he says, okay, let's join. And so now he becomes a part of the natural number. But since natural number starts from 1, if you look at it, if 0 should join these set of numbers, well, 0 is actually, these numbers now, it will actually change from count starting from 1, but it's now starting at 0. And so we would not classify a set of numbers that actually has 0, have 0 as the lowest number in the set as natural numbers. So we will actually call these type of numbers whole numbers. So whole numbers are numbers that start at 0 and it goes up. Natural numbers are numbers that start from 1 and it goes up. And so you can actually see the big distinction and the clear concept of whole numbers versus natural numbers. And so one converted 0 to the family, and he's not part of the family, but since that 0 actually changes the definition of a natural number whenever he is around. But if he's not around, those certain numbers are called natural numbers. But as long as 0 is in the midst as the lowest number and in ascending order, it is no longer natural, what is called whole numbers. And so zero becomes so comfortable and he's drinking as well, and the party continues, and he steps over one steps below him, and then was realized that he's actually in a zone that he has never seen before. Probably must say, well, these numbers has some weird looking features. They are like a negative at the left side of their sides and so on. And so he would say, zero is so friendly. So zero says, hey sir, what? First I'm seeing you and so on. What are you doing here? And negative response and says, I'm actually here with my family. My family are what we call negative numbers, and we are very large. We have up to negative infinity, and so zero would just say, like, why don't we all become a one? Why don't we all become one big family? So if negative actually says okay, and negative family, the other negative family agrees, then if we have all a set of numbers like this, now we have negative and positive joined together. Well, the definition of whole number and natural number could no longer exist, and so they have to be called different names. So that name is what we call integer. So integer is actually negative and whole numbers, and so you can actually see that some of these numbers are overlapping in some other type of numbers. So when you look at the natural numbers, actually in the whole number, but not all whole numbers are part of natural number, because whole number has zero in it and the natural number doesn't have zero. And so you can see that whole numbers are actually, starting from zero going onwards, natural number starting from one going onwards. But integers are just a collection of negative and positive, including the zero. And so when we define integers are negative numbers and whole numbers. And so any number that you pick, negative, positive, zero, you're actually talking about integers. Let's look at another set of number. But if I should take two integers and I should write them as a fraction, let's say I write this as a fraction. Now, this kind of representation is what we call a rational number. So a rational number is basically the ratio of two integers, or basically a fraction of two integers. Well, if you should take two integers and you actually write them as a fraction or represent them as a fraction, you actually get what we call a rational numbers. So rational numbers are basically, as I said before, the ratio of two integers, or two integers that are being represented as a fraction. And so we could actually look at rational number in a different way. What if I have, let's say I have 0.7. How could I convert 0.7 from a decimal to a fraction? Well, we know that this is actually being divided by 10. And so if you look at 7 and you look at 10, 7 and 10, they are actually integers. And so we could actually say this fraction is a rational. So when you look at, let us look at another one. What if we had, let's say we have 0.06. What would this be as a fraction? Well, it could be 6 over 100. If you look at it, 6 is an integer, and 100 is also an integer. And so we actually seen that these kind of decimals are also coming from rational expression, a rational representation. So when you look at it, all decimals that have a terminating period, all terminating decimals are called rational numbers as well. All decimals that have finite amount of decimals, they are also called rational numbers, because these decimals are basically representation of two integers as a fraction, and we actually prove it. So let's look at another set of rational number. What if we had 0.3? 3, 3, 3, 3, 3, and it continues. Now these decimals are what we call reoccurring decimals, or repeating decimals, and this can also be represented as a fraction. We could say 3 over 9 is the same thing as this, and so you have 3 and 9. These are actually integers, which are actually rational numbers. So reoccurring decimals are also what we call rational numbers. If you also have a number like 17 divided by 99, this is actually 0.1717, and also, as you see, it is actually reoccurring. And yet, not only that, you can actually take 799. They are actually the family of integers, and so when you have reoccurring decimals, or we call them terminating, because there's an end to the decimal, or finite values of decimals, we refer to them as rational numbers. And so if we probably look at let's look at the root of 9. It is 3. Would you say the root of 9 is actually square root of 9 is actually rational? Well, if you look at it, 3 is an integer. So if 3 is an integer, that simply means, and all integers are rational numbers, therefore 3 must be a rational number. And so the root 9, square root 9 is actually a rational number. What if we have a number like, let's say, 5, square root 5? Would this actually be a rational number? Well, let us look if it has any features of rational number. What are some of the things that we look at as it relates to if this should be a decimal? What should it be? Let us find out. So square root of 5 is what? 2.3, well, 23607977, and continues. And if you realize this digit is a non-terminating decimal digit. The decimals are continuing. There's no end. It's not a finite it doesn't have a finite representation, and therefore these kind of numbers like root 5, and let us try root 7 before I tell you what is actually happening right here. And so we have let's see 7. So we have this is actually 2.6457, and it continues. And so whenever we have these kind of numbers, these kind of numbers are not rational numbers, but they are what we call irrational numbers. So irrational numbers are numbers that have actually, well, a non-terminating decimal. It also it cannot really be represented as a rational representation. So whenever you have decimals that are non-terminating, we refer to them as irrational numbers. And we can look at some more examples. Look at pi. Pi is actually 3.142, I think 85 something. And it continues. Now pi is not a rational number, but it is actually an irrational number because it has a non-terminating decimal. And so that's why it is. Well, let me find the specific value for pi. I think pi is what? Let me see. 3.142015926, and it continues. So it continues. So it is not stopping. It is not. There's no termination to it. There's no end. And so we actually refer to these as irrational number. Another number we can actually look at, which is our irrational number, is the number e. And now e is just a constant that we use in mathematics, in probability, statistics, in logs and and some of these mathematics that we actually use, exponents and those things. And so it basically gives us a decimal that does not have a finite cutoff point of numbers, and so we refer to these numbers. This continues. Refer to these numbers as irrational numbers. So there you go. And when you have like square root 3, square root 7, square root 10, and some of these numbers, we cannot represent them as a rational. So when it can be represented as a rational or integer, we actually look at these numbers as irrational numbers. And so there you go. We look at classification of numbers. We look at the natural number, which starts from 1 and it continues. That starts at 1 and it goes and it continues, which we also call counting numbers. We look at all numbers, which starts at 0 and it continues to infinity. Integers, so negative and positive values. And we look at irrational, which is simply an expression of two integers as a fraction. We look at, and also with the rational, we look at that numbers that have reoccurring decimals, terminating decimals, or finite set of decimals are also called rational numbers. And we look at the opposite of that, which was irrational, which doesn't have any reoccurring decimals or repeating decimals. And so we look at a few of the type of numbers that we use in the number system. There are many more, but for now we'll be looking at the